All right, in this video, we're going to be using the integer root theorem to list out all possible and candidate roots of this polynomial function. One thing we should already know about the integer root theorem is that we're going to be able to do this by using our constant term. Now, if you look at this polynomial function, one thing that's interesting is where they have that constant term. Remember the term that does not have the variable attached to it. That's going to be 2, okay? One thing that I would recommend you do is you rewrite it out in standard form so that you move that constant term to the end and take the linear term of negative 5x and push it in front. This is not something you have to do, but I would recommend you do it just to set the problem up, making it look like this. Now that you see your constant term at the end, we know that that's what we're going to be using to find our integer roots. All we need to do is find our factors of that constant term. So let's list out 2 down here and let's split it up, giving our factors. We know that it's a prime number, so we know that 1 and 2 are the only 2 values that can multiply together to make 2, but we also want to include the opposites because a negative 1 times a negative 2 would also give us 2. So what are our possible candidate roots here? It would be positive negative 2 and positive negative 1. These would be your integer roots for this polynomial function. Let's go over another one. All right, here we have another polynomial function written out for you. And it's kind of oogly ugly if you tell me, because we've got stuff moved all over the place. We've got our constant right here in the front. We want to put these powers in descending order. So let's just rearrange this, make it look nice and neat the way we want to see it. 5x to the power of 4, negative 28x cubed, plus 7x squared. Linear function of plus 7x, or term, plus 40 on the end. Okay, so all they're trying to do is they're trying to move these terms around on you and hide that constant, make it a little bit trickier for you. But we now see our constants right here. We're moving it over to the end. So we need to now find our factors, all of our factors of 40. So that's going to be quite a few more than the last example we just went over. So let's list down 40. We'll give all of our factors of 40. That's going to be 1 and 40, 2 and 20. 3 doesn't multiply by anything to make it, but we know 4 and 10 would. 5 and 8. And then 6 or 7 cannot multiply and make 40. So we've got all of these possible factors of 40, but we need to also include the negative 1 times a negative 40, which would create positive 40 as well. So we got to list out each one of these values. Make sure to include both the positive and the negative. 1, positive and negative 2, positive and negative 4, positive and negative 5, positive and negative 8, 10, 20, and last but not least, 40. These are all of our possible integer roots of this function up here. Again, just find that constant, write it down, list out your factors, and those are all possible factors of the function. Study hard and good luck on your upcoming test.